Hello friend, good evening. So today I'm going to take a very important topic on tubular and destructive testing. So in this case, in the tubular we are taking for the various technique for testing of tube inspection. Okay. So let's start. So before going ahead, if you are first time you are looking my channel, so you can subscribe if you like my videos. Okay, thank you very much. So let's start. So for various technique for testing of tubes, there is a first technique is the remote field testing. Second is the your ED current testing, and third is the your internal rotary inspection system. It is also known as the iris. Okay, and fourth is the your magnetic flux leakage testing. Okay, so these are the four testings which we do for the testing of the tube. Okay, now we will start for the first technique, remote field technique. Okay, remote field testing. Okay, so about remote field testing, if you see there is a maybe this is the your tube. Inside you will insert this, and there is your probes which is the going inside the tube. Okay, this is the your tube. Okay, so how it work, it used to inspect the ferromagnetic material. It only used for the ferromagnetic material. We are using our probe inside the your tube. Okay, so use a probe which is inserted into tube. Okay, the third, if you see, the probe contain a exciter coil and receiving coil, which excited coil generating a magnetic field. So when it goes to inside this your they have a coil, exciter coil and receiving coil, which exciter coil generating a magnetic field, which they create the magnetic field. And how it create the magnetic field, because if you see, so they behave like this. Okay, they behave like this. Okay, so if you see in this case, means how it work, it is behave like this. So your this is the your direct field, and if you see it goes like this. So this is the your transition zone, and these are the your magnetic flux lines which working in the both areas. And so if you see absolute how it work, actually how it work. So if you see how it will be work, absolute response. So it will be it is behave like this. Okay, absolute response. If it is your differential response, so it will be it will work like this. Okay, so how it work, if you see, if I can tell you, inside this is the your tube. Okay, and this is the your this is the your coil. Okay, so how it work, if you see your magnetic field, they are creating like this, in this case both the side. Okay, so it will be work like this, and this is the your pipe wall. Okay, and this is the your exciter coil. So if you see this is the you're known as the magnetic field, how it generate the magnetic field from the exciter coil. Okay, so from the exciter coil, probe is pulled through the tube. As the probe is pulled, magnetic field of the exciter coil created eddy current in the tube. So how it work, so this eddy current create another magnetic field of its own, and exciter field is dominant, but eddy current field extend more in the tube. Okay, so how it work, as you know, magnetic field line of eddy current is cut by the moving receiving coil, and this produce an electromagnetic forces in the receiving coil. Monitoring the voltage induced in receiving coil can help in direction of flow in specimen. Okay, so if there is any leakage, so as you know, if it is the your if there is the leakage, and if your magnetic fields are the, it will be moved like this. Okay, understand, huh? As you know, so if there is the flux changes, as you know, if there is the flux changes due to why, due to material loss. So if inside your tube is the material loss, so your flux will be changes. And if you see differential receiving coil for the detecting the flux changes, so you can see where these changes will be come out, how it will be behave. And if you see the in your screen, so like take examples, tube diameter from exciter coil, and this is the your detector amplitude volts. Okay, so if you take 1 2 3 4, and if you take 10 to the power minus 7, 10 to the power minus 5, 10 to the power minus 4. So how it work, take examples this, so it will be go like this, and it behave, how it will work. So if you see the image, it will be go like this, and third, if you see how it so this is the your transition zone, and this one is the your ID phase, and this is the your OD phase, and this is the your ID amplitude. So this phase angle degree, and if you see in this side, this is the your 0, 90 and 180. So this is the your phase degree, you can see in this line. Okay, so in this case, if you see, this is the your location of your probe. So if you see, then there is a many zones, like this is the your like direct coupling zone, after that transition zone, and then remote field zone. Okay, so it will be that there is a 3 zone direct coupling zone, where your this is the your means this magnetic field is the location, exact location, and then transition zone, and then remote field zone. So direct coupling zone is the area. What is the direct coupling zone? Is the area where there is a strong eddy current. So direct coupling zone, there is a 3 zone. So first is the direct coupling zone, and this zone is the area where is the strong eddy current, and transition zone is the area. Second is the your transition zone is the, and the third one is the your remote field. So remote field zone, that it start approximately 2 tube diameter away from the exciter coil. Okay, so there is a 3 type of the zone. Okay, so how is detection of the flow? Where there is no flow, phase of the receiver signal with respect to the phase of the exciter signal is directly proportional to the sum of wall thickness within the inspection area. When a flow is met, multiple changes will occur. Flow can detected. Flow may be corrosion pitting, crack, or erosion thinning. Okay, so what instrument will be used? They will use the instruments like multi-frequency, RFT, or ED current instrument, accessories, then RFT, dual, exciter, bobbin probe, and third is the RFT, amplifier, and fourth is the grounding cable. Okay, so these are the, okay, so let's start. For the second is the RIS. RIS is the known as the, as I said before, internal rotary inspection system. Okay, so RIS is the ultrasonic method for inspecting pipe and tube. Can be used for both ferromagnetic as well as the RIS can be used for the ferromagnetic and non-ferromagnetic. It can be used ferromagnetic and non-ferromagnetic material, and produce very accurate results up to 3%. Okay, in the RIS, if you see the RIS, how it functions, the RIS is the like this is the your pipe or tubes, and this is the your instrument is the going, it is the your I'm not good in sketch. Okay, so sorry for this. This is the your water fill, and this is the your back. Okay, so if you see water, and this one is the your mirror is in front, this is the your tube, and there is the your target pin, and this is the your transducer. And if you see, this is the your known as the turbine, and this is the your probe body and water, and this is the your centering device. Okay, so how it work, before the test tube is needed to be the clean before the inside, then it must be the flooded with the water. So first need to be the clean and then flood with the water. So you have to take in precautions, clean and then with the water. Iris probe then inserted in the tube, flooded with the water, then after full of the water, and then you have to insert this one iris tube, iris probe, and probe consists of ultrasonic transducer which direct an ultrasonic beam towards a mirror which is the inclined 45 degree. So this is the mirror and it is inclined the your 45 degree with the tube axis. Okay, so how it works, probe consists of ultrasonic transducer which direct an ultrasonic beam towards a mirror which incline a 45 degree of the tube axis. Beam fall on the tube surface at the right angle. Beam is partly reflected from the inner surface and partly transmitted and again reflected from the outer diameter surface. The time difference between the two signal is used to measure the wall thickness. So how it work, then you will get the echo. So this is the your A scan. So this is the your back wall, this is the your front wall, and this is the your target. Okay, as the mirror is mounted on the water, dravine rotates 2000 rpm, and probe is pulled through the tube slowly. Whole of the tube surface is tested. Better understanding of this we can analyze. Okay, so how you will interpret it, there are the 150 reading per revolutions and about 2000 revolutions per minute. So interface is screen, so 3 results for the better understanding. B scan gives the B scan 2D display of the transverse cut at any location of the tube length. C scan give the plan view of the tube is rolled out of flat, and D scan give 2D display of longitudinal at any circumferential position. Okay, so some facts about the is used for the detecting, where we use for the detecting for the pitting, corrosion and wall thickness, and it is difficult to detect crack. Crack cannot be detected, not for the crack. Okay, can be used only on the tube with the tube diameter tube diameter 30 mm or above only we can use. The accurate result probe must be the move slowly. Probe must move slowly 2.5 centimeter per second. A supply of clean water minimum is required for the clean water. Okay, so that's all. Thank you very much for watching my channel. Okay, don't forget to subscribe my channel. Thank you. Goodbye.